A very good morning to Dr. Azim and fellow friends. So we are going to present our mini project titled Improving for Future MRT Project. So we are from Group 6 and my name is Caucasian matrix number 206019.
My name is Karunation bin Anwar, 205951.
My name is Muhammad Azhar bin Muhammad Shah. My matric number is 206567.
Hello everyone, my name is Muhammad Afiq bin Jamal Muhammad, matrix number 206003.
I will proceed with the introduction. MRT stands for Mass Rapid Transit. It's a real system which is used to transporting passengers in urban area. It's become a very big option for getting people from one location to another in a short amount of time. The company who runs this MRT is MRT Corp Sdn Berhad with the goal of developing and owning the MRT system asset. MRT Corp in charge of procurement process, contact ordering, construction monitoring, and others. Until now, Malaysia have MRT 1 line that have 51 km from Sungai Buloh to Kajang and MRT 2 with length 52.2 km from Sungai Buloh to Putrajaya. Nowadays, Malaysia are towards having next third MRT line known as Circle Line. The circle route will form a loop of orbital line will encircle the KL center core, while also connecting most of the rail line with construction over a 10 years period. Now I'll talk about the brake system. As we all know, all transportation have brake to ensure they can control the speed and stop in desired time. Brake is an important feature in order to stop the MRT within the minimum possible time. Braking system used in railway vehicles is essential in high-speed train by convert all parts of kinetic energy of the moving vehicles into form of energy to enable deceleration and control acceleration during downhill or keep them maintain rest when parked. A proper brake system can let driver react to handle the vehicles during emergency contingencies, and brake should be effective enough to help remain constant or stationary position even on the prolonged application or during descending down gradient with environmental influence like wind or rainfalls. So why this brake system is important? Because it can secure the safety of human life and the physical resources. So there are 4 types of classical brakes: pneumatic brakes and electrodynamic brakes, mechanical brakes, and electromagnetic brakes. And factors affecting brakes are the weight, the pressure, thermal events, brake functional types, and the design of the brake. I will pass my session to Afiq.
Okay, thank you, Kyo. Now we'll move on to on how to improve this braking system that Ko has mentioned. So there are 2 things we can improve on. The first thing is the brake disc, and the second thing is the braking system itself. So as for the brake disc, I will now tell you what makes brake disc a good brake disc. So a good braking disc serves to dissipate the brake energy to heat and then to remove this heat by means of cooling fins. So meaning that it's able to accept heat and also release heat in a very orderable manner. So the main concept here is thermal. So as what Ko has mentioned, so the friction between the disc and pads generates a significant amount of heat. So that's why we have taken this into account and decided that we will use the 30 CR&I MN steel brake disc that is used for the China high-speed train. So this material is ideal to withstand the thermal fluctuation acted upon it, because after braking, the heat convection of the brake disc does not exceed 5% of the heat generated by the friction in the usual conditions, so it can't be neglected. This is based on a research, so it is proven. So that's for the second improvement that we can make is on the whole braking system itself. So in conventional trains or conventional means of a train, the braking system that is used is mostly a hydraulic braking system. So what we do with this is also the same thing. We take the China high-speed train as a reference because they use the same thing. They use a much more improved hydraulic system. So in this improved hydraulic system, it consists of 3 groups of function. The first one is microcomputer brake control unit, as in MBCU. The second is electro-hydraulic braking equipment, and the third is basic braking equipment. So these are the main components of the braking system. So the reason why we use this braking system is because the system works with high reliability and it requires less maintenance. It can be used in high speed and it is collision proof alongside other known benefits such as it is compact size, it is low cost, it is easy to set in automatic control and link with other parts of train. So this benefits, it correlates with our time, it correlates with all the safety mechanism that we need in our MRT project. In addition, there are 2 systematic controls that need to be stated in the presentation, and that is there is the brake control and there is the emergency brake control. So based on the name, you can already see what is it about and what is the function. So I guess that is all from me. Now I will move on to Nashran to present his slides.
Okay, usually wheels are made from the steel or iron. So our good suggestion to replace the steel material with the titanium. So why titanium? Titanium has a high tensile strength and modulus of elasticity, and it is strong enough to replace the steel as a material. It has a good corrosion resistance, lighter than steel, and excellent in fatigue and fracture strength and fracture resistance. Titanium has been used in many things such as building industry. There is Hotel Marqués de Risca in Spanyol. Titanium has a high demand in aerospace engine, usually used for fans and compressor. Also used for military and surgical plate. And lastly, used for new rover tires that made by NASA for Mars mission. It's been stated that this tire can support heavy load. Next. So we want to minimize the radius of wheel. So from the RapidKL Facebook page stated that diameter of wheel that have been used in MRT1 is 850 millimeter for maximum and 775 for the minimum. So we cannot use the radius below 775 because it will be inefficient. So when the smaller radius is chosen, it will give a larger force for the apply on the wheel and increase the acceleration. And then when we choose the smaller area, we will give the smaller area and tends to increase the stress and automatically increase the elasticity. That's all.
So benefit from the replacement of steel with titanium alloy, the strength of the material can be maintained due to high yield and ultimate tensile strength and also high elasticity even lower than steel. Second, titanium alloy can prevent from rusting for a long time. Third, the lighter material can increase the speed of MRT. Benefit from choosing a smaller radius, it can give more elasticity due to more stress, and also smaller radius can increase the speed of MRT. In conclusion, improving braking system application in MRT project will make more efficiency braking system and will help MRT stop in emergency or within less time and distance. In addition, the riding quality of MRT passengers can be enhanced with a good braking performance. Furthermore, the performance of brake system also influenced by many material parameters such as good wear resistance, high strength and thermal resistance, and low cost and ease of maintenance of the system component. The material and equipment must be developed in order to meet the need safety requirement for the MRT project. Moreover, replacement of titanium for material of wheel can avoid the wheel from rusting, since titanium has higher corrosion resistance. Last but not least, decreasing the radius of wheel can increase the speed of MRT and it will give more stress applied on the wheel. That's all from us. Thank you.